this is a worked example on how to graph secant and cosecant functions. In this example, we're just going to do secant, but the idea is the same for both. Um, I'm going to assume to a degree that you already understand how to graph sine and cosine functions. If not, I think you can go back to worksheet 7.2, and that covers sine and cosine. But that's important to know because what we're essentially going to do here is graph the corresponding sine and cosine function and then graph secant on top of that. So, we're taking advantage of the fact that secant is the reciprocal of cosine. So we're really graphing this function. But to make it easier on ourselves, we're just going to graph cosine, and then we're going to draw secant on top of that. So temporarily, let's just, here, I'll erase this for now, and I'll do it in yellow. We're just going to graph cosine of t minus pi over 2. And so if we look, okay, the period should not be anything because omega is 1. Well, the period will be 2 pi, which is standard. So I shouldn't say it's not anything. Period is 2 pi. I meant to say nothing special. And then we'll have phase shift. This will have interesting values. That's going to be, right, negative phi over omega. And, just a reminder, we're looking at cosine of omega t plus phi. So this is going to be positive pi over 2 divided by omega, which is 1. So the phase shift should just be pi over 2. Amplitude and baseline, there's none in this case, but those are pretty easy to take care of. So remember, cosine looks like this sort of graph. It starts at 1, then makes a full cycle, and that would typically have a period of 2 pi. And so in this case, we're shifting over by pi over 2, and we're still traveling 2 pi. So if I want to find the full distance that cosine travels, I can take pi over 2 plus 2 pi. Okay, and so if I turn 2 pi into 4 pi over 2, that makes me be able to add it, and that's 5 pi over 2. So I know that my graph, and before I start really drawing it, is going to look like, well, it's going to start at pi over 2, it's going to end at 5 pi over 2, and I have it starting at 1 here and ending at, not negative 1, and ending at positive 1 here. And then it's going to make a full loop in the middle. Okay, so let me erase this for now. And again, I'm going a bit fast on the cosine part because I'm sort of assuming that we already know some of these things. So starts pi over 2, it ends at 5 pi over 2. And now I'll graph it in white just so I have nice looking axes. Well, here, I'll make the axes in white and then, okay. All right, so hopefully my face cam doesn't block too much of this. All right, and now what we're going to look at is I want to place my starting point, pi over 2, and my ending point, 5 pi over 2. And again, these tick marks might not be super accurate, but then what we want to keep in mind is that the values of interest for cosine occur at the intervals of 1/4 the way along the axis. So my first interval of interest will be in the middle, and then my second will be here, and my third will be here. Okay, so let's see. The period is 2 pi, and so if I divide that by 4, I get pi over 2. So my intervals should be moving in pi over 2 increments. So the first interval right here, that'll be pi over 2 plus pi over 2, which is 2 pi over 2, which should just be pi. That'll be my first interval. Then we'll get pi plus pi over 2 as the second interval, and that should be 3 pi over 2 right here. And then the last interval, we have 3 pi over 2 plus pi over 2, which is 4 pi over 2. Okay, so that's our scratch work. setting up our axes, and then we're just using the fact that cosine has all of its points of interest at these axes. So I'll add points for 1 and -1. I don't want to make them too lopsided. I know that I usually am not great at graphing, but I want to make this look as nice as possible because I know that trig functions can be confusing. Okay, so cosine starts at 1, it intersects the axis, it goes to -1, intersects the axis, and goes to 1. And now I can connect this graph. Completely missed. Oh, I forgot the other intersection point. There's an intersection point right here. Okay. Now let's try and graph this. Okay. That looks horrible. Let me try that one more time. Down. Here. 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 Okay, that looks a lot better. All right. So this is our graph of cosine, as bad as it might look. But now, what we're going to do for secant is we're going to fill in the information on that graph based on cosine. So remember, again, secant is, and where should I write this? So we'll do it over here. Secant of any theta is 1 over cosine theta. So any point where my graph is 0, I'm now going to have an asymptote, right? Because if you remember from rational functions, if you divide by 0, you get that undefined value at an asymptote. And any place that I have 1, you're going to get a value of 1. And so what we can kind of do is we can kind of start to fill in information as well, right? So the 1s will match up on the function. And so I'm going to use green to graph my secant. And I don't know why that keeps erasing. Yeah, why does it do that? Okay. So all my 1s will match up, and then anywhere I have a 0, I have a vertical asymptote, so I can try and add a dotted line through the 0s, like this. And now I can kind of fill in the loop-looking thing. I mean, that's my best way to describe it if you know what the functions look like. I'm going to start here, I'm going to move in this direction and kind of go up towards an asymptote. Again, here, I kind of move up towards an asymptote here, up towards an asymptote here, and then this guy moves up towards an asymptote here. And that is what and I'm almost off the screen, I kind of am, but that is what secant will look like. And if I really want to, if I was doing this on pencil for a test, I can go through and I can erase my cosine values. I don't want to try and touch those 0s because I might erase the whole axis, but that is what secant looks like with a phase shift of pi/2. So again, whether you're doing secant, whether you're doing cosecant, graph the corresponding sine or cosine function first, and then fill in the information like I did here. It's a really quick way of graphing. It's very efficient. Gets you a really nice looking picture. But anyway, that is a worked example on how to graph a secant function.